Hey, welcome. So, we live in this world of just invisible connections, right? Our phones, our laptops, even our homes are constantly sending information through the air. But have you ever stopped to think, is any of that actually private? Who else might be listening? Well, that's exactly what we're going to dig into today. Okay, picture this. You're at the airport, your flight's delayed, and then you see it, that glorious sign, free airport Wi-Fi. I mean, it's so tempting, isn't it? But is hitting connect really a safe bet? Let's break down what's actually going on behind the scenes when you do. So here's the absolute key to all of this. Unlike a wired connection, where your data is tucked safely inside a physical cable, wireless is a broadcast. That's it. Your emails, your passwords, your messages, they get turned into radio signals and shot out in every direction. Your data is literally riding radio waves through the open air, just like your favorite song on the car radio. And that right there, that's the wireless world's big, kind of scary secret. Because your data is being broadcast. Pretty much anyone nearby with the right and honestly, surprisingly simple tools could just listen in. We're talking about grabbing passwords, reading your private messages. This is not science fiction stuff. It's just how radio waves work. And the tool they'd use? It's called a packet sniffer. A packet sniffer is basically a digital eavesdropper. And we're not talking about super secret spy gear. It's just a program you can run on a totally normal laptop to capture and look at the data, the packets that are flying through the air. And on an open, unsecured network, like that free airport Wi-Fi, those packets could contain your login details, credit card numbers, really anything you're sending or receiving. So wait, if all our data is just floating out there for anyone to grab, how is the internet even a thing? How is it usable? Well, the answer, and our digital bodyguard in this story, is cryptography. It's the science of secure communication, and it's built on three fundamental principles that act as our protectors. And these three pillars are confidentiality, authentication, and integrity. You can think of them like a team of security specialists, and each one has a totally critical job. If even one of them fails, the whole system is in trouble. So let's meet the team. First up is confidentiality. This is all about secrecy, pure and simple, and we get it through something called encryption. This is the magic that turns your readable bank password into complete and utter gibberish before it ever leaves your computer. So even if a snooper does capture those packets, they can't make any sense of them, not with a secret key anyway, which only you and your bank have. Next, we've got authentication. This is all about proving you are who you say you are. How do you know that free airport Wi-Fi is the real airport network and not free_airport Wi-Fi with a sneaky little hyphen set up by an attacker in the next terminal over? Authentication is that digital ID check that verifies both you and the network are legit before anything important gets exchanged. And rounding out our team is integrity. This is your guarantee that the data hasn't been secretly messed with along its journey. Think of it like a digital tamper-proof seal. It makes sure that the email your friend gets is the exact one you sent, with nothing added, removed, or changed by some person in the middle. Okay, so how does this whole security team actually work in the real world? Well, let's start with the wireless network we all use every single day, our home Wi-Fi. Believe it or not, this team is hard at work right there in your living room. The history of home Wi-Fi security really shows you how important this is. The early standards were, well, let's just say they were not great. They were easy to break and left your data totally exposed. But modern standards like WPA2 and now the even better WPA3 are incredibly strong. They use powerful encryption for that confidentiality piece, and they require a password for robust authentication, which basically locks your home network down tight. So every time you connect a device to your home Wi-Fi, this cool little digital handshake happens in seconds. First, authentication. You type in the password. If it's right, your device and the router do this clever exchange to create a brand new, totally unique encryption key, just for this one session. And from that moment on, confidentiality kicks in, and every single bit of your data is securely scrambled. All right, so that's Wi-Fi covered. But what about when you're out and about using your phone's 4G or 5G connection? Well, it turns out cellular networks actually have a pretty crucial security advantage up their sleeve. The key difference is a little something called mutual authentication. See, with most Wi-Fi, you prove your identity to the network with a password. It's a one-way street. But with cellular, your phone proves its identity to the cell tower, and the cell tower has to prove its identity back to your phone. It's a two-way ID check. And that is a huge deal because it stops your phone from getting tricked into connecting to a fake cell tower an attacker set up just to spy on you. We've covered the big networks, but these exact same rules apply even on a much smaller scale, with a technology we all use constantly, Bluetooth. Yep, that connection between your phone and your wireless headphones, your smartwatch, or your car stereo, that's actually its own tiny secure network. The very first time you pair them, that's the all-important authentication step. And after that, they use encryption to keep the connection confidential, making sure nobody sitting next to you on the bus can listen in on your phone call. So let's just quickly recap the big takeaways here. First, wireless is a broadcast, which means it's open by its very nature. Second, our digital bodyguard is cryptography, which uses that awesome team of confidentiality, authentication, and integrity to lock things down. And finally, the modern standards we use for Wi-Fi, cellular, and Bluetooth are all built on these exact principles to give us the security we need every single day. And all this leaves us with one last big question to think about. We've gotten pretty good at securing our phones and our laptops, but now we're connecting everything to the internet. Our watches, our refrigerators, our security cameras, our cars. As billions of these new Internet of Things devices come online, the challenge isn't just about making them convenient. It's about how we apply these same core security principles to all of them. How we solve that problem? Well, that's going to define how safe our digital future really is. Thanks for joining me.